Hi ladies, Mr. O'Sullivan. Today is Friday, March 26th. We are going to be looking at lesson 6-6, which is exponential decay word problem. So we are we're almost wrapping up this unit. We actually have 2 more lessons left. When we get back from the break, we're going to have a quiz on that Tuesday. We're going to review for it on Monday together, and then Wednesday labor work day. So today's learning target is I can solve a word problem containing exponential decay by creating my own exponential function. And here's the thing, whenever we see the word decay, this word right here, I want you to think of getting smaller. I want you to think of really getting smaller. So let's write that in. Decay means to get smaller. So the exponential decay equation we're going to use, it's a very special formula. It's similar to the one we had yesterday. It is y equals a times 1 minus r to the t power. So yesterday, we looked at exponential growth, and we actually had a plus r. So we're going to be looking with 1 minus r. The same thing is a is your initial amount, r is your percent as a decimal. Make sure that you divide that number by 100. And t is time, and that's typically in days, years, months, minutes, etc. Make sure that you read the context of the problem, because you actually might have to do a little quick conversion. And there's an example today where we have to do a conversion. So to find your decay percentage, let's do a quick practice with that like we did yesterday. You have to look at the number in the parentheses. If it's bigger than 1, it's growth. If it's smaller than 1, it's decay. So the number is not your percentage. You have to find it, and that requires you solving that one-step equation. So for each of these examples, we want to find out the initial amount, if it's growth or decay, and we want to determine the percentage rate of increase or decrease. So if I look at my first example, I have y equals 270 times 0.99 to the x power. I know that the number hanging out by itself, so my 270, or the number attached to my parentheses, is my initial amount. So I can say 270 is my initial amount. Now I have to look at the number inside my parentheses. So in this case, I have to look at my 0.99, and I have to figure out, is that growth or decay? Well, the number 0.99 is less than 1, so this is an example of decay. Now we need to determine that percentage rate of increase or decrease. Well, we know that since this is decay, it's decreasing. So we're going to be doing a 1 minus r, and we're going to set it equal to 0.99. So I'm going to do 1 minus r equals 0.99. Now to solve that equation, I subtract 1 from both sides. I get negative r equals negative 0.01. And this is really a negative 1r, so I divide both sides by negative 1. And I get r equals 0.01. Here's the issue. That tells me what r is. It doesn't tell me my percent. So now I got to take that number and multiply by 100. And I get 1%. And that is your rate of decrease, your percent of decrease. All right. Now let's look at our next example. I have y equals 70 times 0.96 to the x power. The number hanging out by itself again, or attached to your parentheses, is still your initial amount. So if I look at this example, my initial amount is 70. Now I look at the number on the inside of my parentheses, so I look at my 0.96, and this is an example of decay because it is smaller than 1. Now I go down here to determine the percentage rate of increase or decrease. Well, I know it's decay, so I'm going to do a 1 minus r equals that inside number. So 1 minus r equals 0.96. Remember, this is really 1 minus 1r. So I'm going to take away 1 from both sides of my equation. So I get negative 1r equals negative 0.04. Now I divide by negative 1. Divide by negative 1, and I get r equals 0.04. Here's the issue. I want the percentage, so I have to multiply by 100. When I multiply by 100, I get 4%. Let's go into our final example. Y equals 700 times 0.726 to the x power. I got to ask myself, what's the number? That's my initial amount. It's the number attached to my parenthesis, so it's 700. A lot of 7s today. Now I have to ask myself if it's growth or decay. Look at the number inside your parentheses. It's a 0.726. So that's smaller than 1, so this is a decay example. Now determine the percentage rate of increase or decrease. So this is a decrease situation because it is decay. So I'm going to do 1 minus r equals that inside number. So I'm going to do 1 minus r equals 0.726. There's really 1 minus 1r. So now I'm going to take away 1 from both sides of my equation. Get negative 1r equals negative 0.274. And now divide by a negative 1. And I get r equals 0.274. Here's the issue. I want the percentage, so I got to multiply by 100. And I get 27.4%. And that's your final answer. So this is a 1% decrease, a 4% decrease, and a 27.4% decrease. Okay, let's go into some word problems. Please note that these models that we're doing are based upon the amount that remains, not how much disappears. We're not subtracting, we are decaying, okay? So the first thing we're gonna do is I'm gonna actually copy and paste this equation. I'm gonna put it right here. That way we can see it at all times. So I know the A is my initial amount, the R is my percentage as a decimal, and I have to divide by 100, and T is time. And I have to be very careful because I might have to do a conversion. So let's look at our first example. You buy a new car for $24,000. The value Y of the car decreases by 16% each year. So I'm going to highlight my 16% and my 24,000. I know that this is my A value and this is my R. So part A says, write an exponential decay model for the value of the car. So we know it's an exponential decay because it's telling us. So I know my generic equation is going to be this right here. So I'm going to rewrite Y equals A times 1 minus R to the T power. So I have to ask myself, that A we just said was 24,000. So I have Y equals 24,000 times 1 minus. I can't write 16%. I need the decimal. So I'm going to go to my top. I'm going to write 16 divided by 100. And that'll give me 0.16. So I'm going to do 1 minus 0.16 to the T power. And that's your final answer. So I can say this is my equation for decay. Y equals 24,000 times 1 minus 0.16 to the T power. Part B says, use this model to estimate the value after 2 years. So what we're going to do is we're just going to plug in 2. So every time I see a T, I'm going to plug in 2. So I'm going to do Y equals 24,000 times 1 minus 0.16 to the second power. And I'm going to type that on Desmos. So I'm going to do 24,000 times 1 minus 0.16. And I'm going to raise it to the second power. And I get this number right here. I get 16934.4. So I can say Y equals 16934.4. But the thing is, you typically have 2 decimals after money, so this is our final answer. So the car is going to be worth 1,690. Oh, I missed a number. Sorry, I missed a number. That doesn't make sense. The car is going to be worth $16,934.40. Okay. So that's what I get when I plug it in. Now, part C says, when will the car have a value of $12,000? So I want to find out when. So basically, how many years will it take for me to get to $12,000? So if I want this, I actually want to find out what my Y value is. I mean, my T value. So I'm going to do 12,000 equals 24,000 times 1 minus 0.16 to the T power. So I want to find out what this value is. So what we're going to do is we're going to write out this part. So we're going to write Y equals 24,000, 1, 2, 3, parenthesis, 1 minus 0.16, parenthesis, and I'm going to raise it to the X power because we don't have a T key. Now, I want to find out when it's going to hit 12,000. So I'm going to actually convert this to a table of values. So I'm going to hit Settings, Table, And I have all these possibilities. So if you look at year 2, I hit 16934.4. So that doesn't really work for me. So I'm just going to type in random x values. Now that I want to figure out what's happening at 12,000, I'm actually going to delete these numbers above. I'm just going to type in random numbers. I type in x equals 3, and I hit 14,000. That's not 12,000. I type in x equals 4, and I hit 11,000. So at some point in year 4, I'm going to hit $12,000. So I'm going to say t is approximately 4. So I can say that it will take 4 years. Now let's go on to our next example, number 2. The amount y in grams of a sample of iodine 131 after t days is given by y equals 50 times 0.92 to the t power. So if I look, I'm given this equation, and part A says identify the initial amount. So ladies, what is the initial amount of my substance? Well, if I look, the initial amount is the number attached to my parentheses. So in this case, it is my 50. So I can say my initial amount is 50. Part B says what percent of the substance decays each day. So if I look, that's when I have to go to the inside of my parenthesis, and the inside of my parentheses is that 0.92. So I'm going to set 1 minus r equals to 0.92. And I'm going to solve this equation for r. So I take away 1 from both sides, take away 1, I get negative 1r equals negative 0.08. Now I divide by negative 1, and I get r equals 0.08. Here's the issue, that gives me the decimal. I want the percent, so I'm going to multiply both sides, but I'm going to multiply by 100. So I multiply by 100, I get 8%. So this is a 8% rate of decrease. Part C. How much of the substance is left after 1 week? If I look up here, this is not measuring in weeks, this is measuring in days. So I actually have to ask myself, 1 week is how many days? Well, that's 7 days. So I'm going to be plugging in 7 to my equation. So if I look at my equation, they give it to us. We don't have to create it. It's y equals 50 times 0.92 to the t power. So everywhere I see a t, I'm going to plug in 7, because it's 7 days. I'm going to go to Desmos, and I'm going to type it. 50 and I'm typing it exactly as it's written. And when I type it, I get this long, long number. I'm only going to go out 2 decimal places. So I get 27.89 as my final answer. So I can say y equals 27.89, and that tells me that there are going to be 27.89 grams left of this substance after 1 week. Okay? D, how many days does it take to only have 10 grams of the substance left? So that's when you want to find out your time value. So I'm going to be setting 10 equal to my equation. So my equation is 50.09 times 0.92 to the t, and I'm going to set it equal to 10. So my equation is going to look like this. And we want to solve for this value. So if I look, I'm going to go back to Desmos. I'm going to type in y equals, so y equals 50 parenthesis 0.92. And I'm going to raise it to the x power this time, because I don't know what x is, so we want to find it. I'm going to hit the setting, change it to a table, get rid of my negative 1 and my 0 by backspacing. And I want to find out when I'll hit 10. So I'm going to just type in random numbers, just keep on going, keep on going. I'm going to hit enter. And if you look, I don't hit 20 yet. 10, sorry, I don't hit 10 yet. And I want to find out when this number will be 10. So I'm just going to keep on hitting enter until I get 10 to the right. I don't get it. This is a little annoying. Keep on going, keep on going, keep on going, keep on going. I don't hit 10 yet. I hit 10.255. Boom, I hit 9. So by 20 days, I will have 10 grams left. So I would say T is approximately 20. So 20 days. And that's your final answer. And that's it for today. So ladies, there was no Delta Math yesterday, so you will have a Delta Math today on a mixture of growth and decay word problems. This assignment will be due after the break, so please make sure that you have it done and it's a good review for your quiz when you get back. If you have any questions, email myself or Ms. Townsend. Have a great day, ladies.